Assume that women's heights are normally distributed with a mean of 63.5. So I see there is my mean, and a standard deviation given by 2.2 inches. It says if one woman is randomly selected, find the probability that her height is between 62.7 and 63.7 inches. So what I'm doing is I'm finding this area. So of course I'm going to need some z values, but remember when I find this first z value, it's going to give me this area. The second one will give me this area, so I'll end up having to subtract the two. So I like to call this the z lower, which is 62.7 minus the mean divided by the standard deviation. When you're given a number of individuals, then you also divide by the sample size, but in this case it doesn't matter because the square root of 1 is just 1. And then I'm going to have a z upper, which is the 63.7 minus the given mean, all over 2.2 and square root of 1. So I put all this stuff in my calculator and I got negative 0.36 and I got 0.09. So remember what those values are. If I standardize my graph here to a mean of 0, then this is the lower, because of course it's a negative, and this is the upper. So if I look up negative 0.36 in the table and I look up 0.09, I could subtract these two and it would give me my area. So I'm looking for negative 0. So negative 0.36. So that looks like that's going to be 0.3594. And then I'm looking up 0.09, which is going to be that value. So 0.09, 0.5359. So those are the two values that I'm going to subtract to get my area. 0.5359 minus 0.3594, and that gives me 0.1765. So that's my answer to part A. Part B, you do the same exact thing. The only difference in this part, see if I can maybe erase some of that, there we go. So the only difference in this part is dividing, oh, I probably wanted that, is dividing out, get back to my pen, let's put this back here, was 2.2. So the only difference in this part is they give me 10. So my z lower is going to look the same, minus 63.5 over 2.2, but in this case I'm going to divide the square root of n, my sample size, which is 10, and then z upper is going to look the same, 63.5 over 2.2 divided by the square root of 10. This one I get a negative 1.15, and this I get a 0.29. So I'm going to look up those two z values. A negative 1.15 looks to be 0.1251, and a 0.29 looks to be 0.6141. And so going back here, I'm going to do the same thing. I'm going to take 0.6141 and subtract 0.1251, and I get 0.4890.